All right, welcome to today's stream, everyone. So, as I had posted, today we are going to take this AI created image of a Apple experience for the Vision Pro, and we're going to start out a schematic design in Rhino for it. Now, I've been doing a lot of Blender in the channel. Why am I using Rhino? Well, the reason for that is I'm taking this approach from building out the actual design first, and then we'll visualize it later on. And for that, I do like to use Blender to kind of get more creative with it. But simply saying you can do precision modeling and you can do CAD work in Blender. Should you? Well, that's kind of what I'm trying to answer today. After doing a lot of work in Blender, I still have trouble doing precision modeling in Blender, and it may just be because of what I'm accustomed to. But I am faster in Rhino for this type of thing. So let's go. First off, we're going to create some views in Procreate. So I have my reference image in here. Just going to make it smaller, move it off to the side a little bit. Actually, we can just keep that as a perspective on the top right. So what I usually do here is I'll create a new layer, and I haven't really fully figured out how to screen share from Procreate. What you're seeing now on the screen is actually just a progression of the drawing itself, not actually what I am looking at on the iPad screen, but you know, it gets the point across. So what I'm going to do here is just go to my architectural brushes and grab the dashed line. And first things first, we set up a guide to stick everything flat. So we do a drawing guide with a grid. You're also not seeing that, but you see there's a grid in the background. That's essentially what I have in front of me right now, so that I could draw a, let's enable the drawing guide. I have my shortcut set to double tapping on the pencil. It's just what's easiest for me because I'm constantly having to use the drawing guide. So we'll just cross right there. And we can first take out the pencil. So I'll go over to sketching and grab a 6B pencil. Now, I could just start making this in Rhino, sure. But there are things that I can consider when sketching that aren't really apparent in 3D. So a lot of people, what they'll do is they'll just start designing in 3D and they'll rotate around their model over and over and over again, trying to have the model scream back at them what it is that you need to do. And I just find that sketching is quicker for iteration. The hand to mind connection that just doesn't somehow exist in a mind to mouse just isn't there. So it's like, for example, even with assisted drawing like Procreate, if I turn off my drawing assist and make my pencil smaller, I can draw in a perfect circle right here by drawing a circle and then holding down a finger on the screen, and I have my footprint, right? So what I want to start doing now is just start cutting into it basically as though I'm cutting like right through the middle for a floor plan. So I'll draw a straight line. I'm going off of my grid a little bit here. That's nice. So now I can kind of thicken these walls. And what I'll do is I'll actually now duplicate this layer. Just kidding. Well, I will duplicate it, but now I need to erase everything else in it because I drew everything so far on the same layer, which is, no matter how much I remind myself to do, and from what I've seen from other people who are very professional at this, it's an error you keep making, but it's fine. There we go. Now we have this separated to its own layer. And there we go. So now I can cut out this outer circle. Erasing right there. Cool. So there we go. We have that solid portion. Now, to something that the AI did that's pretty sleek and nice. Around here, let's highlight some stuff. There we go. I do really, really like this band that we have going on with the chrome, but it is facing outward a little bit. So how that would look in floor plan would be to actually just bring in these edges out a little bit, just like so. And I'll just kind of do it freestyle there. Also, if you don't have a chance to just do sketching in your free time, you got to do it sometime. So might as well use AI to start just sketching out your ideas. And as I've spoken before in this channel, I like to rationalize what AI does, right? Kind of like read into what it has, but obviously sometimes it makes mistakes. So from those mistakes, you can be creative, right? You can actually start to make sense of what it is the AI intended to draw there, or you fill in the gaps, right? Reminds me of Mad Libs. If you've ever played that game, it kind of has these funny sentences and you just kind of fill it in with your own words. Okay, not bad. So we have a layout. Now, we have this opening on this side, right? And what I want to do is I want to have people come in through the opposite side, so we keep this full glass experience for people to see maybe what it is that people are doing inside, like using the AR thing, or maybe there's some sort of movie playing towards the outside. I'm not quite sure how to resolve the whole AR thing yet, but what I do know is we need an opening right here. So that's it right there. We'll put some steps, and it could be cool to kind of have some type of flooring or footing. So I'll kind of create a pad right there. Sure, don't love it, but you know, maybe. So taking a step back and being a little less literal. So for example, creating a new layer so I can move this around freely. There we go. And we just have a circle here. So now it's more interesting compositionally to make sense of this because it's a circle with another circle, right? So I kind of take a step back. I stop thinking about it being an opening, having steps, or like how many people I'm going to fit outside on top of this thing. And it's more about how do I make these two circles look good in floor plan. And close attention also to the outside shape, that crescent moon that's ending up on the outside, because that's really what's primarily experienced. So you know what, I'm using my grid here, and maybe that's biased and makes it look good, but I kind of like that positioning for it. So there we go. This is also why you keep our things in separate layers, because you can erase and draw through things. All right, and then the layout for inside. So first of all, we need a little reception area where you check in. So that can be, let's see, I don't want to make it huge. I'll just strike right there. Okay, so that's one zone. And now my other zone is just going to be this right here, where you kind of wrap around this after you've checked in. Right? This is my whole like thinking behind the experience. You walk in, you waited in line and whatnot. You walk in and you come up to the desk here, right? They give you your headset, they like set you up, you take your waiver and whatnot, and then you walk out onto the outside. And maybe your waiting position is like right here, even before you go to the desk, and there's something playing on the screen right there. And then after you wrap around, this is kind of your play area. This whole thing right here. So if this whole area right here is for the VR AR experience, that's essentially where you have that glass panel. So what could be cool is for the inside of that glass. So for it not to be like just fully clear two ways for that window, but from the inside, this window is actually tinted or toned down. This one here, I'm just squiggling it to call it out. So that could be interesting because then we can have video playing on this screen and video playing on this screen. And maybe it's the same video, right? So it's video that's being instructional about how to use it. So essentially you're looking out toward have this landscape outside with people, but you're not really paying attention to the people. You have they're sort of like muted out with the rest of the city on the view outside. And then this is basically an instructional video taking you through the experience. And maybe that's happening in conjunction with what's going on in the VR itself, like you're running through a tutorial. What's cool about that is you could set up speakers here that are giving that same tutorial out to the public, and then people on the outside are able to look at either screen and follow along what it is that the person's probably experiencing. So that could be cool. All right, let's hide all of that and bring it back to the floor plan. So we've got our screens right here, and well, right, I'm not trying to be diagrammatic anymore. I'll just kind of call this out as a curved screen in both places. We got a floor plan going. There's another screen right here, so we need some thickness. And finally, this is just the glass panels, so we can add a little divider here for four glass panels. And I would love to have drawn that panel towards the middle. Awesome. Okay, that's enough to go on for the plan. So let's move on to the elevation. So interestingly enough, I'm going to be designing this kind of from like a side view, like I'm cutting a section through it. So that's going to look like this right here, as though I'm cutting a line right through there. Let's make that line visual mode orange. Cool, our section's cut right through there. Let's go back to our sketch, pencil, and I'm just gonna quickly like sketch out with the drawing assist on vertical lines running down, so these can get hidden later. But this essentially helps me stick to the proportions that I have going on up there. So I'm actually going to do that with several things. I'm going to do that with the wall as well. I'm going to do that with the end of the screens here. Basically any main markers I should be considering for that side view. If you're an experienced designer and you're like, or you went to architecture school, you're like, yeah, of course, it's top view, side view, you know, typical stuff. But you'd be surprised how many people either forget this or just don't do it. Skip this part. Okay. There we are. So that's about the proportion. I think I maybe went too short. Yeah, for sure. Let's keep that hidden. I'll just work on this top layer. Okay. All right, now the proportion for that little footing is very little, and it sort of extends a little bit beyond the middle there. I'm just kind of eyeballing this because really what I'm exploring here is the proportions that I'm seeing on the right hand side of the screen. And although I'm using the drawing guide, I'm like very quick and rough with it at the moment, just trying to get basically an idea of how tall things should be, how thick things should be. That's really my only concern. I'm gonna poche in here just to kind of see a little bit better where I'm cutting this section. Cool. What's neat about the edges on the AI image too is it kind of makes it look like it's thinner than it actually is, or like it's floating, and that's because we've just got some corners cut in just like that. I just forgot, I have not brought up the chat. I updated my stuff and my chat didn't come up. Let's see. Okay. I don't see anything in the chat, so sorry viewers if something has popped up so far. You could retype it in, or here, let's do this. I'm gonna go quickly make sure I got no pending messages. Generate, hey, nice to see you. And EM, so I do have chats, I do have comments. If I said yet, but what do I think of the Vision Pro? And can I check my sound connections? My sound looks like it's going all right on my end. And generally, sorry I didn't have my chat up sooner, But as I sketch this section, I'll let you know what I think of the Vision Pro. So, I don't know. I mean, a lot of people are complaining that it's just too expensive or like dumb features that it may have and whatnot. But really, it's not meant for the everyday consumer, I don't think. Some people have even argued it's for, you know, VR or tech enthusiasts, and I don't even think so. I think right now the point is to have people who develop to get something like this as part of R&D. Like, I think they made it very, very clear that since this is coming with a new operating system, the people who will be buying this, and why it's not I don't even know if it's coming out next year or 2 years from now, I forget. But it's going to give them enough time to basically build out also the developer kit for people to come up with their own apps. So I really just think the people that should be really seriously considering getting that are people who are already in that space and are looking to kind of be developed. Is it for, you know, an enthusiast or consumer for tech? I mean, I don't think so. Like, I think it's too crazy for a gaming machine, for at least like what's out there for VR gaming so far. For 3D rendering, or like if you're familiar with, what is it, Gravity Sketch is a popular app that's used to basically make 3D models in VR. Works really, really cool, or really, really well. But yeah, I don't even think like that's a good application for it. So, but the argument here, or the argument for it, is that it's one of the few VR AR headsets that has some features that are really, really cool for it. So first of all, they're planning to put the M2 Ultra chip in it, which makes it a supercomputer. So no other VR headset has that kind of chip in it. Even the more higher end stuff has really, really cool graphics, or the way you get really, really cool or really like amazing interface and graphics is to having it hooked up to an actual PC computer or Mac computer. So having the M2 Ultra in the headset makes it a supercomputer. It's, I think, the same chip that they're putting in the desktop version of the new Pro. I might be wrong there, but it competes with it. So it's not an accessory to another device. It's in itself a whole computer with its own operating system. Another cool thing is, just like the iPad has like the sidecar thing for Macs, where you can just see your Mac screen on the iPad wirelessly or wired, and it works perfectly, amazingly, like it's an extension of the computer. So they're going to have that for the Mac as well with the Vision Pro, where you're just going to see your Mac, you're going to look at your Mac screen, and then it's just going to float up in midair, and you basically have more monitors for your Mac. I mean, those really make good cases for it being, you know, taken seriously as far as like an actual, like, really high-end experience. There's some other things if you want to check out MKBH. I'm sorry, I'm screwing up your YouTube name, man, but MKBH has a video where he like tried this out. He doesn't like actually show what he did, but he talks about the experience of the Vision Pro, and he says it's basically seamless. Like the whole pinching thing and the whole user experience is just buttery smooth. So I'm all for that, because the nausea that comes with being in VR for too long, or the eye fatigue and all that, can get real. Okay, so we got a side view, we've got a top view, and typically I then do like a front view or a perspective, but I think we're good here. What I'm going to do is I'm going to export this image now. As a JPEG is fine. I'm going to save somewhere handy. I'm going to move over to my computer screen. There we go. There we are. Found my folder. Okay. So now we're in Rhino 3D, and we're starting out with a sketch. So we can bring this in from the iPad into Rhino. There we go. And I just dragged that in from a folder, real easy. Cool. Now we're working in 3D space. So we actually need things to line up to actual dimensions and whatnot. Okay, let's see if hopefully unplugging the iPad fixes those audio issues if they're still persisting. And we'll take a look at creating a cylinder. So first things first, I mean, I've got a whole thing beginners for designing Rhino, so I'm just gonna kind of go through this quickly. I'm gonna be using volumes mostly to get this done, or solids rather. So we start out with a cylinder, and I'm gonna actually make the cylinder how big I want this thing to be. So let's say I want it to be 30 feet wide. I'll go 30 feet. Oop. There we are. And that's huge. And then however tall, right? So we're going tall now. I'm just gonna, so right here we're at 9 feet, 10 feet. I'm gonna go like 14 feet. That seems comfortable. Okay, so I did some real dimensions for that, and it was way bigger than the image. So what I need to do is I need to scale up the image, and I'm just clicking and dragging this little scale on the gumball and holding shift to scale everything evenly, and make sure that I place this thing. Ooh, that was pretty close. Just place that thing right within the circle. Cool. So now I have these things lining up, and I'm gonna select my drawing, and I'm just gonna lock it. Boom. So I can't select that anymore. It's locked in place. I am gonna move this cylinder though to my other layer, layer 1. And here I'm gonna call layer 1 my volumes. So I'll keep it 01, so everything is neat and organized. Volume. Cool. Now we need another cylinder for that entry platform. So we'll just go ahead and do another cylinder and kind of eyeball it in size. How big do I want this to be? Just a couple, maybe like half a step, like 3 inches. Okay. And place that. So I'm not too concerned with making every little part of this thing at the moment. Again, it's just blocking out the different volumes. So I'll create another cylinder for the bottom. Make sure I can snap to the center of that existing cylinder. This one's gonna go out just a little bit and then come up. So this is where I should have my other drawing. So right now I'm just gonna eyeball this maybe there, but I will unlock my drawing, copy paste it, rotate it 90 degrees, and then in side view right here, move it. Use wireframe mode over here. Oh, it is in wireframe. Move that image back. There we go. So the scale on this one is actually going to be correct already, like in the sketch, because I already shifted it over. Let's lock that. So I would have to adjust whatever it is I'm modeling here to the size of that. So maybe I went too tall in the sketch, which is fine. I'll just imagine that that stuff is lower. I can copy paste the cylinder and bring it up. Not too concerned with being perfect right now. Just kind of aligning things around. And okay. Now I need the portion that cuts through the center cylinder. So this inner cylinder is actually the glass panel in the inside of the wall. So what I need to do what I need to do right now is copy paste this top cylinder. I'm gonna shift click in order to just select this bottom face, and now I'm gonna use the move command to snap onto that edge, for example, and bring it all the way down here. Oh, that shifted sideways. Control shift click again to grab that surface. Hit move. There we go. I can look for a seam. So this vertical line right here is a seam. I can do endpoint to endpoint. That'll make it easier. All right. And then I'll control shift click to select this top face. And let's move that face right here. Okay. So now I kind of have like a top cap, a bottom cap, an outer wall, and an inner wall. That's basically just where we're starting out. Oh, and our little circle outside for the platform. So how do we start now making all this become this structure, right? Well, we're going to start using booleans to basically create this shape right here and then mess with the edge conditions a little bit. So really what that is, I tried orbiting like I could see the side of the AI image. We're just going to cut a rectangle right through this thing. So we're going to go to top view and do a box. Actually, the command is box. We'll line that up to the inside wall a little bit. Be kind of loose with it. And we're actually going to snap this only to the middle of the sphere or the cylinder. The reason for that is we want it to be the exact same size on both. So the way to do that is we're going to just do it on one half and then mirror it over to the other. And then we make sure that that way we make sure that it's centered. So we do mirror now. Boom. Now actually, I think this would be wider. Cut through it a little bit wider. But first I'm going to Boolean union these two. Right, so now it's just one shape. I can do scale 1D to basically scale from the center outwards. So it's scaling also mirrored. I think that's pretty good right there. I think that matches my reference a bit. Yeah. And I want to do scale 1D over and over from the middle to the top of the bottom cap and the bottom of the top cap where it already is at. Okay. Next, I can throw in some walls just to wrap up these volumetrics. So let's do the walls that we had set out right here in floor plan. So we'll do, keep snapping to center. I'm gonna turn off center snap. So I can just kind of pick a point right there. There we go. Bring that through using all three views right now to draw out some walls. And that's our little counter. That has to become shorter. Scale 1D from the bottom to its own middle. Yeah, that's nice. It's gonna have to actually scale to be counter height. So we could do 36 inches. Cool. Let's do a high counter. Let's do 42 inches. All right, and we can use one object to trim out the other. Essentially here we want to do a Boolean difference. We'll do Boolean difference. Subtract from this rectangle using our inner cylinder. There we go. Boom. It did the outer difference. Oh, I want to do Boolean intersection to get the inside piece. So let's see, I'm trying to get the middle there. Select the inside one and then deselect everything else. Let's try that again. There we go. Now if I hide my walls, we'll see we've got our counter area there. All right, so similar to the sketch, we had our volumes and we've got our areas all set up. Now I'm gonna select all this stuff, copy, paste it, and change it all into layer 2 so that I can always refer back to my volumes in layer 1. So now everything goes purple, and we'll call this our schematic. Yeah, that's fine. So we can do Boolean difference. Subtract from. So we're going to subtract from everything, kind of. We're going to first do a Boolean union. Nope. of the outside and inside wall. So what this is going to end up looking like. Ooh, where's our inner wall? Unhide everything. Oh, I screwed up. Or I thought I had something set up in a certain way and I didn't. So the Boolean intersection that I did, go here to shaded. If I do Boolean intersection, select first set of surfaces and polysurface, and it says delete input, yes. Delete input, no. Click there or do D, enter. I don't want to delete my input so I don't lose my inner wall, which is what just happened. All right, so there we go. That did not work. Boolean intersection. Boom. Select the second set. We just did this. Come on. Hide. Oh, I guess it's not deleting the outer portion either. So we will delete that because we don't want it. Okay, we're good. So now we'll move on to copy pasting this and moving it over to layer 2. Layer 2, our schematic. Okay. And now we can do Boolean union for the inside and outside wall. So they become 1. So actually, the inside wall is sticking out the bottom. I want to go into wireframe here. Take that inside wall. There it is. Do scale 1D. So I can scale it from the top to meet the same places that the outer meets. So the top of the bottom cap, top of the bottom cap, and the bottom of the top cap. There we go. So if we look at it in ghosted, there we go. We've got these two matching up perfectly now in top and bottoms. So we can do Boolean union, and that should give us some inside walls. Nope. We got to give it some more thickness. So I'm just going to scale this inward a little bit so they're not perfectly meeting. So if we do difference, that's why. So we'll actually keep that where it was. Boolean difference. Subtract from the outside one with the inside one. Yeah, it's kind of weird to think about, but if we move this out of the way now, basically we just hollowed out the outside cylinder with the inner cylinder. So now we have everything we need for the wall. Okay, so next we'll do Boolean difference, subtracting from the outer walls with the cube, and then we can delete our cube. We can also delete this one here, and boom. We've got our opening, although we'll have to tweak that edge later. We have our bottom cap and our side cap. Okay. We also forgot to add in a little rectangle here as our entryway. So this cube should be, we'll make this door 2 feet wide. So I'm going to do this rectangle 2 feet. There we go. And we'll make it maybe 9 feet tall. Kind of a big entryway. Cool, and I also want it to be an arch. So I'll add in a cylinder. I can add in a cylinder from this front view. There we go. So it grows out this way, just so I can make an arch. All right. Not too concerned with modeling everything perfectly here. There we go. Mirror this. Boom. Move the circle down. Let's move the top of these rectangles down as well to just kind of fit within the cylinder. There we go. Oh, actually we can move that and snap it just to the side of it. There we are. So I can now do Boolean union on all these shapes. And now Boolean difference. Huh. had to make it deeper. I'll just stretch it out like that. There you go. Boolean difference. All right. Cool. Let's wrap this up today with doing a neat little band over there. So let's bring back our reference. Yeah, so what we have here is like this top facing and bottom facing surface that sort of curls outward a little bit right there. So there's a really interesting way that we can get to do that. And it involves bringing back some of our reference geometry, which is why we always want to keep that. So we can see our inner circle or inner cylinder here. And I have to rescale this to, once again, meet the top of the bottom cap and the bottom of the top cap. Cool. I'm going to duplicate that and bring that back into layer 2. So just copy paste, put it to layer 2. And hide that layer. All right, so this is our glass, and then this little edge here is our circle, right? So I can't really move this along the circle because it'll distort the rest of the wall, like very nastily. So we kind of have to rebuild that feature there and ultimately do a Boolean union onto the side here. So I will do Control Shift click. So like this face. Oh, just kidding. The command doesn't. I do want to isolate that face, but the command I'm about to use, which is dupe face border, doesn't require me to select it beforehand. And now it says select surfaces or faces to duplicate border. I'll select here, and now we have a curve. So we want a curve because I can now do offset. I can offset it inward. We're going to hit D to change the offset distance. And the offset distance should just be the thickness of this wall. So we'll do that from top view, wireframe. We'll find the seam for this thing. There we go, perpendicular. Now we've set our offset distance. Then we just offset it inward. And it should match perfectly to that edge right there. And I don't need to repeat the process for the bottom. I can just select these two and do copy and copy it from the top to the bottom. All right. This is where it gets tricky or neat. I guess I didn't need both the outside and the inside yet, but it's fine. What I'm going to do here is I'm going to do a polyline that just traces this edge right here on both sides. Cool. So now if I select everything I'm going to use, I have this edge, I have this edge, I have this top circle, and I have this bottom circle. So I'm basically just going to cut these curves and join them together to create an outline of this opening. Okay. So we can just hide everything except those curves right now. And our reference. Cool. There it is. So we'll keep those inner circles just in case we need them later. But for now, I'll do trim, select cutting objects. Those would be our vertical lines. And then hit enter and cut out. Boom, the rest of the circle. And now we select these curves and we hit join. All right, and then they're joined into one closed curve. Bring everything back that was hidden. We have this outer face right here. So look at our reference again. So we want to extrude this face inward, basically, but then also curve it. So we can do that first. So we could do let's do the curve first. So we could do a fillet. Let's see. All right, and then we set a radius. So I'm first going to Select here. I think it's the radius was way too small. Oh, unable to fillet the curves. The fillet may be too big. The curves may not be on the same plane near the fillet. Well, they're not, definitely. Let's see. I might have to turn this into a surface. Let's see if we do boundary. You know what? There's a better way to do this. I'm gonna explode. So unjoin these curves, and what I'm gonna do is I'm gonna select the bottom curve. I'm gonna do extrude curve to the top. Okay, now I'm gonna go to my solid tools, and I'm looking for edge, fillet edge. Yes. In order to fillet edge, we first want to add some thickness to this one. So we'll do an offset surface. Let's bring everything back, because that face, that little band, right, essentially follows that same opening. So we're going to do an offset surface, and we see some arrows pop up. It's going to offset outward. We actually want it to offset inward, so we will just click on it, and it flips the arrows, and then we want to change the distance. So we'll hit D, enter, and now it's prompting us to give it the distance. We'll go back to our top view wireframe and just select the thickness of the wall there, and I think that's all we need. Corners round, solid, yes. We'll do corners sharp. Solid, yes. And both sides, no. Delete input, yes. Okay. So there's our outside band, right? We kind of see it there in wireframe, although we have a front and a back face. So this is where fillet edge is going to come in and give us that opening. So we're going to do fillet edge. Select edges to fillet. So it's doing 1 inch, which if I see the preview there on the side is way too small, right? So we're just going to eyeball this from our reference. I'd say it's even almost like a foot. So we'll do next radius in the command, 1 foot, or 12 inches. That's closer, but I think we still got to go bigger. We might go 2 feet or 18 inches in that. So next radius 24 for 2 feet. Yeah, maybe even more actually. We'll go 32, not quite 3 feet. Oh, I did 42, 32. There we go. All right, that looks good. So let's commit to doing that to each side. We'll do boom. And this one, and this one. All right, very nice. Now I can click on it, do explode, and delete the front face. And there we go. We've got our little band. We bring everything else back. And we basically just want to peel this edge back. So I'll delete that, or hide this rather. I'm going to peel this face back, so I'm going to grab this edge and this edge. There we go. Control Shift click just to select those edges. And I'm just going to move them on the x-axis. Oh, I guess they got separated from everything else. I'm going to make sure that I join them together. Join. There we go. Now it's all one. So if I click this and I peel it back, beautiful. It twists the other shape. So we can take these, and again, just kind of eyeballing it with the reference back there, moving it along the x-axis just slightly. There we go. And actually peels back quite a bit more. And something else you might notice is it wasn't like a perfect, I mean, that's pretty close actually. For whatever reason, this is slowing down my computer. And this is why I'm wary of using solids when it gets to this kind of sculptural stuff, because solids, all these faces are basically calculated in real time by the computer, rather than meshes where you actually have like these faces that you're pushing and pulling. Generate back for sure. Every VR is early. Getting great apps for them is one of the biggest problems. It's cool that Apple is able to do that. Oh, do that with the hardware. Quest made a big advance the same week too. Color pass-through and high resolution. I think that's the biggest thing for VR, and the biggest concern that was existing previously is the whole pass-through thing, which is an amazing feature I think to have, because you can kind of just quit the full VR experience or have it kind of be hybrid. And I think that was a real concern or good hurdle to get through, was actually allowing the VR headsets to be AR. I think ultimately where we want to be is AR. Love Marquis' channel, followed him for years. Yeah, Marquis, the man. Really honest reviews on tech. Okay, doing a bit more calculation here to our band, but we got it. We got our little curved face. It's not exactly what's seen in the AI image, but I'm happy with it. Not sure why it's taking... It says transforming sub-objects. So I guess I'm complicating the arches a lot by just moving these things around, and that takes quite a bit of calculation to do this. You know what it is? It's maybe the fact that it's two objects at once. Because I know Rhino is a single-threaded program for the most part. And it's probably it's trying to do two things at once, which is not, it's not good at. Unless you're doing Grasshopper or instancing. But, you know, there we go. All right, we've got our glass. Let's hide that out. Well, that's our actual glass. So now we see that the glass isn't fully fitting now to the new shape after having distorted this. And we also see that it's distorted this edge like in a really weird way, which I was hoping was not going to happen. But we'll undo back to this point. Perhaps even one more. Okay, so there our face was pretty well done. Oh, you know what? I'm gonna redo all that. Okay, and we'll do this a different way. We're gonna do dupe face border again, so we can duplicate our borders here. So we have these outside curves, and we see that the outside curve is actually clean. It was the face that got screwed up. So what I'm hoping here is if I do explode now, this is now 12 segments. Let me just separate this so we can see. So it's isolated over here. Okay, so now I'll join these three. Join and join. And let's try lofting in between. Okay, so much cleaner. So basically what we did there was just isolated both edges and then built a surface in between them. And that surface that got built in between is much cleaner. So we'll have that replace that existing screwed up surface. There you can see the difference, right? I love this sort of process in Rhino to construct and deconstruct things, because when geometry screws up, like it just did, you kind of can just rebuild it very quickly in a way that can serve you. Now we want to mirror this over, trying to find a middle point. There we go. Cool. Mirrored. Also, we got to delete this glass now, because since this is distorted, it's fine. I'm just gonna, I mean, it should be perfect, but nothing is. I mean, the glass wouldn't really even be this shape. It wouldn't have these curved edges. The glass would just like slot into the wall. So that wasn't even the middle. Come on now. Oh, I can line it up to the floor. So we'll just move this. There we go, to that band. So the glass would actually be a full panel that gets fitted into there, but for the sake of this video, we will do the following. I will do dupe face border again of this and this. and this. Explode. Join these inner edges together. And the thing is, like, then when you send it to a fabricator and you give them this weird curved edge and curved glass wall, they're just going to be like, yeah, you're going to get straight edge curved glass panels, or even like plexiglass probably, and it's just going to slot in. Like, we're not going to curve the edges in there, that it's just going to slot into the curved walls already. But for the sake of this model, it can be like this. That's screwed up. I tried extruding up. Maybe I didn't join them first. Yeah. So I want to join all these curves together first and then do extrude curve. There we go. So it extrudes upward. One input was not extruded because it would have been an invalid surface. All right, that's fine. We'll do rebuild curve. Or just rebuild? Yeah, just rebuild. And how many points do we want to rebuild with? We'll do 50 to stay precise. Now we should be able to extrude the curve. Nope. It would have been an invalid surface. Why is this an invalid surface? I see it. Output surface, direction both sides. No, solid, yes. Let's do output sub D, sure. Nope, not that either. Okay. So I'll copy paste this, project it to C plane, delete input, no. Did it project? If we hide everything, it did project. So what I did there was I just kind of projected it to the ground, so it'd be a flat curve like this, and I can put this to the middle point now, hoping I can loft these two together. Yes, and now I can mirror it to the top piece. Nope, mirror from the front view. There we go. Bam, and then join those two. All right, now my glass fits my ribbon. I can bring everything else back. I hate this outer surface now because it doesn't match. So what I would have to do... Ooh, deleted more than I intended there. Because I have this, and these are loose. And silly me, I deleted that whole solid I had created earlier. So I suppose I just have to... Excuse me. Can I offset this surface? Can I give it thickness? No. Well, let's see. Let's take a look at the reference. I'm complicating it too much because this is actually all cut up into radial panels. So what I can do, I'm going to take this top and this bottom, I'm going to rotate them from their center. I'm going to make this seam match the edge right there. Because essentially what I need to do, looking at the reference, is build out each individual part. So for example, like I'd extrude this piece up. I can do a fillet edge on this top edge as we did before. Keep it at 2.8. Sure. That looks similar, but not exact. That's fine though. And we want to do the same to the bottom. That's a sort of effect. Actually, the bottom is a bit more complex than that even. So if we hide our reference, I'm just gonna do it from memory now. I'm gonna move this up, or actually copy paste it first, then select the face, move the face up, because what this face actually does is it angles inward just a little bit, and then you have another base piece which is black and facing inward as well. So I will scale this face in just to show you what I just did. Okay, so that face scaled in. I'm going to take this face, scale 1D, and bring it down to the others level, scale it even more, right? And then fillet edge that bottom. We'll do a radius there of, I don't know, 6 inches. Oh, that didn't change. Next radius, 6, yes? Yeah, that's good. Okay. Oh, I misread that a little bit. No, it's just too drastic. I made that too dramatic. We'll bring it, reel it in. There we go. Just slightly inward like that. And I imagine that we want to, no, we don't want to fillet edge this top piece. We want to keep it flat as it is there. Okay, so now we have this, this and this and this to join as our aluminum band. And we've got our outer cylinder to still solve for. So we don't have one at the moment. We'll bring it back from our red model. So outer cylinder, copy paste, change over to our new layer. Okay, and we want to subtract basically that opening as it is from this outer one. So how will I manage that? I will select or duplicate this one, rather, hide the one I want to keep. Let's go into wireframe mode and see if I can't use trim to solve this. So if I hide, oh, I've got to bring everything back, hide everything that isn't what I need right now. Okay. And I'm gonna, yeah, hide the glass even. So that's it. I just have my outer cylinder and my glass piece here. And I'm gonna try and use trim, which can work for cutting surfaces with surfaces sometimes. So select cutting objects. I'm gonna select, not that curve, but this face rather. Come on now. Oh, the whole poly surface. There we go. So we have this as our cutting object, and then we'll hit enter to select objects to trim. And if I just click right here, it just disappears. So that doesn't quite work because it doesn't fully reach the outside. Oh, because I pulled the edge in. I actually have to grab these faces. And you know what? I'm only going to work with one side. It's an easy fix. We'll just move this all the way out to the edge there. Apparent intersection. At what moment in time did I do it like that? I don't know. I brought in that other cylinder. Oh, because this is punching in. Right. Okay. We're just going to grab this edge. We're going to go to top view. And we're just going to snap it to this edge right here. Or even this edge out there. Okay, come on now. Even better. Let's select the point, vertex. If I move this point, everything moves with it. So let's select that vertex there and this one here. And I need that to match the edge of the circle. So can we, yes, if I hold shift, I can lock it into that axis and then just snap to the outside of the cylinder. There we go. I could do the same on the other side, or I could mirror it, but I mean, screw it, since it's already all together, I'll just do it to the other side. So again, that's just selecting those vertices with Control Shift click, selecting those vertices and moving them holding shift, and then snapping to the outside right here. I guess there was a middle point here. I copy pasted it. I grabbed it from 2 different ones. So there we go. Yeah, double curves are a headache. Where is that going? There we are. Trying to hold shift here. There we go. There it is. Okay, now we are good. Generally it says, have you been able to try sub-D commands yet? Stopped using Rhino before they came out. Yes, I have used sub-Ds. And to be quite honest, I probably should have been using sub-Ds for this case right now. But you can always convert to sub-D pretty easily. So if I go here to schematic model, save this down. So you can always convert to sub-D by actually hitting, I think it is convert, or let me see, sub-D box to sub-D. Select meshes, surfaces, and extrusions. So if I select these, subdivision options, use mesh control points, use corners, surface corners, whatever. I'm just gonna hit enter. So you see that's the sub-D, and because I told it not to use corners, it just came out as a oval. But like say I took this top surface and I made that into a sub-D. So surface corners, yes. Use surface control points. Delete input, no. We'll hit enter. So the sub-D is a little weird, like obviously it didn't fit fully, but sub-Ds are a bit more friendly. They're basically just curved meshes when I try to push and pull their faces. So you can see there, like it's not taking very long like it was before. And if I hit tab, you can actually see what's going on. So this is similar to how Blender works, or Maya, I guess, where you're tabbing in and out and you're kind of seeing what it is in curved form and what it is in rectilinear form. And all it is subdividing this rectilinear form into this curved form. So to be honest, it'd be interesting and neat to kind of see and compare what what would have been better, the sub-D or the surface way that I just did it. But we got there. Double curves are a headache either way. But we got her done. So, thinking about how I could turn, first let me join this all together. Oh, it won't join. Why won't it join? Join. Okay. Well, in that case, I'll just mirror. Mirror from the middle. There we go. And then I gotta trim them and join them. It's all a little tedious, but that's fine for now. I'm wondering if, let's see, if I bring back this circle, the outer cylinder. Having trouble speaking today. Copy and then paste. Bring that into schematic. Okay. We'll try this trim thing again, since now we see that this is actually, it's peaking a little bit, but not as much as I'd like out of that other surface. So let's copy paste it again. And you know what I'll do is I'm going to do scale 1D from its center to its edge outward. So it should just be extruding in a straight line. This is where it gets really weird, because what do I do now? Do I grab this and pull it forward? It seems to be headed in the right direction. So if I do the same thing for this side, copy, paste, hide that one, and then use this one, scale 1D, and then stretching these faces forward. There's probably a better way to do this, but this is as good as my imagination gets right now. Could I do trim, cutting objects, this one, and then cut into the cylinder? No, it looked like it did, but it just disappeared. Hide. Oh, wait. There we go. Yeah, I guess I don't want to hide this completely. I want to just hide the inside face. There we go. I guess I would probably have to join these together. My problem is I'm being lazy now. Oh, intersect. So let's intersect this cylinder with this and this band. Oops, intersect all these things together. And we get a really, really messy curve. Because it's intersecting everything. So I think I do need to join these. All right, let's do due diligence here. So we can wrap today. I just want to get that outer wall. So we have this one. I'm going to go to the top view and draw a line through the middle. There we go, move that into place. Okay, hide everything except that band. Oops, didn't mean to drag that. Okay, now we're gonna do one at a time. So we'll do trim, and we want to trim this one object. And then we want to trim this other object. All right, so now we have, nope. Trim. There we go. Oh, because we have copies. Keep forgetting. So let's see. There we go. That one's trimmed to the middle. And this one I have to finish trimming. Let's delete the copies. Okay. Trim, and then, yep, that piece right there. Okay, so now I have these two halves. Can I join them? Yes. So now we have the whole band all together. We can copy that. Scale 1D, scale from the middle. Nope. Scale from, see, this is where it gets tricky. I have this one face. How can I remove this from this cylinder? It should be easy, right? Let's try trim now. Trim on the extrusion. I don't think that worked. Nope. Okay. I think I got it. Hide this. Select these faces. Or do dupe, face, border. Select all our faces. Okay, So now we have all the curve edges. We do explode. So now it's 40 segments all together. I'm just going to move this aside. And I'll just start deleting all these little panel curves. That chrome, we have the chrome ribbon before we got the the wall panels. Okay. So now we're going to select these outer curves. And we're going to hit join. 10 curves join into one. We'll go ahead and join all these together too. 10 curves joined. We'll move them back into place. And I'm going to select these curves and I'm going to project it onto our cylinder. Okay. Didn't work because I had to pick an axis, didn't I? Curve, project, loose, delete, direction, Z-plane. No, I want to change that direction. I want to project custom direction. Projection direction. There we go. Draw a straight line now from top view. Just this way. I want to just project outward. Okay. That didn't exactly work as I expected, did it? Control I. Okay, that's kind of no. Let's see here. Undo, undo. Remember when I said in the beginning, people just look at the model and rotate around it. That's where I'm at. It's just that this face is so weird. Such an awkward face. And I'm trying to, and in topology as well. Like, how do I get that to remove from there? I think at this point, it's even easier to just build out each face little by little. Okay, well, no, that doesn't even match. I'm shooting myself in the foot here by having done this as just one, rather than having thought of doing this in panels already, because then I would have just focused in on this piece right here. So you know what? Let's just go ahead and do that. Let's draw a line to the center. Mirror that. Okay. So we have these two. I'm gonna project to the ground, or project to Z-plane, just to kind of create that slice. Delete object input, yes. And from top view, I'm gonna hide everything except that one cylinder. Hide, hide, hide. Okay. And now I'm going to use these to trim out this part of the cylinder. Okay. I mean, yeah, because now I can do dupe face border. I'm gonna have to edit this stream to just cut right to this point here. I'm gonna just duplicate the border for all of these that have anything to do with that face. Okay, well that came out weird, but that's fine. I'm over it. Okay, explode all of that. Well, actually, it has an easier fix than you might think. So I'm gonna just do this side first. We could just select this face or this edge, and then, well, let's just have everything meet just into that one corner. So scale 1D so that this one is just right up against it here. And then this one I'm gonna have to trim because it's a whole cylinder. So we'll select this here. There we go, that one curve. Do trim and trim right there. Cool. Same thing over here, trim. Okay, so now if you see highlighted here in orange, we've just got this little open slice in the form of boundaries. Except for this point, they don't quite line up. So I'm just gonna grab it. If I select this curve, its control point is in there somewhere. Ooh. It's kind of like back there. Let's move into the object. There we go. Ah, because this is not fully lining up. We'll grab this edge and just move that in. Boom. Okay. Now I can take this curve, take that point, move it right there at the joint. Select this curve here, select this curve, and then select this curve. And we can do a command called patch, which should be filling this in. However, let's see, we've got a troublemaking point here. Let's move that down. Curve, curve. I see. There's a lot of weirdness to take care of here. I'm definitely going to try rebuilding this as a sub D, because it's worth just a try. Because I've run into this before with double curves where they're very, very tricky. Okay, but yeah, basically just filling in this outline. Gonna do, we still have this curve up here. Yes, we do. Move that point right there. Line. Select this edge, select this edge, and select this edge. We do join. Okay, join into one closed curve. Now patch. Nope, patch goes all over the place. It might be because it's self-intersecting here. It looks like there's another point in there. Wireframe. Ah, there's several points over here. We'll just move these down. Patch. You know what? We could try it this way. Trim. Can we trim the outside of the face? There we are. Okay, so that's a bit awkward. It would need a little bit more finessing and translation for it to be good for fabrication. It'll work for a render, but at least we get an idea of the material, like the sheet that's going to have to live in there, which is a pretty tricky one. Ultimately, I think even the fabricator wouldn't use my drawings or my model to fabricate this, not because it's well, maybe because it's poorly built or not optimized for that fabrication. But essentially, if you've seen me work before, I kind of go through this process where this is really going to serve as a scaffolding for the 3D model. And ultimately, what I end up using later is a sort of tracing, like a refined version of this. So this is really a way of getting the shape down, getting an idea for what it is that's involved or needed to make this. And later, in another step, we relate this to building materials. There we go. That's properly mirrored. And then this one got trimmed erroneously, but for now, we can just close this edge in. And we've got our general shape. I just got to punch that doorway through again. So yeah, thanks for joining today's stream. When all else fails, just F10, show points, and add points and drag them to where they need to go. True, that is a sculptural approach. General late. F10. So yeah, if we select this object, we hit F10, turn on points for poly surfaces. Turn on points for poly surfaces. I don't see it doing it for me. But I do know what you're talking about, because it does it automatically for me for curves. Like I get all the points that relate to a curve as seen right here. So yeah, we're gonna call it there. I mean, I've had the opening here, I might as well. All right, let's do this cylinder proper. We've got this one curve here. We gotta mirror that using this, okay, so that we can bring our cylinder back. Okay, go into top wireframe. There's our edge to cut with, and there is our edge to cut with. We'll do trim of the extrusion. Bam. All right, now that's closed in. And we'll go over to this side and I'll do our little 2-footer by 2-footer by, how tall did we want it? Is that 9 feet for the entryway? Let's just make it 8 feet. 2 feet by 2 feet by 8 feet. There it is. Move it to the edge. Extrude it out. Mirror it. There we go. We do our cylinder from the front view to get an archway. Boolean union. And I gotta save this shape, so I'm also gonna send it to layer 1 and then duplicate it back into layer 2. Ah, yes, and our inner cylinder. So that we have an inside space. Boolean difference. Outside circle from inside circle. Alrighty, and if we hide our glass, Where is our glass? Unhide everything. Our glass is there, but it's right behind our inner wall, which I see that we still have one. We'll go into selecting our curves here and trim out this thing. Okay. I was planning on doing this other portion tomorrow, but we can go into, well, let's just look at it like this. Boom. And if we bring back our reference, all right. Again, needs refinement, but we're going over a schematic model here, and we're trying to match this thing. I'm using proportions here and dimensions that I know that can work for the space and also for certain paneling techniques and options. But, you know, this will continue to get refined and developed. But really, the next step, or the stream tomorrow, is going to just deal with making drawings of this. So I don't think I'd quite push the model that much further. I could do like a Boolean difference here to clean up the flooring. But yeah, in tomorrow's stream, we'll be taking this schematic model and just start making some drawings, as in to approve this design. So essentially those drawings would just reflect some of the features on the inside. We'll do like a little exploded model where all these pieces are like peeled back, right? We could show the entire space like this, and we'll have that all set up in Rhino as sheets. So it'll be more about yeah, I mean, at this point, it's just a matter of getting this onto Rhino sheets, Rhino layouts, and then if any development of the model needs to happen, it has to be shown in those drawings. There's no point in working the model into more details like this unless you're actually getting into the parts. But as an intermediate step, or what the point of a schematic model would be to just show the viability of the design before you develop it for actual fabrication. So yeah, I'll see you at tomorrow's streams for that. Thanks, General 8, for the compliment. Good night. I will be trimming this stream down because I did get stuck there, but we found a way to get that tricky little face to work out for the intents and purposes of this model. So, all right. Have a great night, everyone. Catch you in the next stream. Thanks for tuning in.